In this video, we're going to talk about OR probabilities. Before we get to that, let's talk about what is a compound probability. This is a probability that has more than one event occurring. An example of a compound problem might be this. What is the probability you select a 4 or a black card? So the words or and are used for compound inequalities. Again, we're going to talk about OR probabilities here. So suppose you select one card from a standard deck of cards. Determine the following probabilities. So before we answer these questions, let's review what is in a deck of cards first. So here I have the deck of cards, of course, without jokers. So there's 13 clubs that are black. There are 13 diamonds that are red. There are 13 hearts that are red. And there are 13 spades that are black. When you add them up, there are 52 cards with this. And there's 4 aces, 4 twos, 4 threes, 4 fours, so on and so forth, up to 4 jacks, 4 queens, and 4 kings. So now let's go back and answer these questions. Okay, what is a probability you're going to select a heart or a black card? So it's an OR, that means I'm going to add. So the probability of a heart or black card is equal to the probability of a heart plus the probability of a black card. Now, the probability of a heart, there's 13 of them out of a total of 52, plus there are 26 black cards, 13 clubs and 13 spades, so that's 26 out of 52. Add, that's 39 out of 52. Divide the top and the bottom by 13, that is 3/4. Now, is it possible that you draw a heart and a black card at the same time? The answer is no, because a heart is red and not black. But you need to be careful about the overlap for this. In this case, there's no overlap. All right, part B, the probability you select a club or a 7. So let's write the probability of a club or 7. It's an OR, so that means I'm going to add. So that's a probability of a club plus a probability of a 7. Now, in this case, I can select both a club and a 7. So I'm going to subtract out the overlap, and let's call it the 7 of clubs. Well, there's 13 clubs in a deck. That's 13 out of 52. There are 4 sevens of 7 of hearts, diamonds, clubs, and spades. And there is 1 7 of clubs because I'm counting that card twice. I got to subtract out 1 out of 52. That's 16 out of 52. Reduce that into lowest terms. That's 4 over 13. Okay, part C, you select a face card or a 2. So remember, a face card is either going to be a jack or queen or king. In other words, any card that actually has a face. So the probability of a face card or a 2, that's the same thing as a probability of selecting a face card plus the probability of selecting a 2. So there's 4 jacks, 4 queens, 4 kings, so there are 12 face cards out of 52. There are 4 2s in a deck. Now, if you're drawing a single card, are you able to draw both a face card and a 2? The answer to that is no, so there's no overlap here. This is also 16 out of 52, and of course that reduces to 4 out of 13. So the first and third examples were examples of mutually exclusive events, since it is impossible to choose a heart and a black card, okay, with just one card, or a face card and a 2, only selecting one card. So mutually exclusive events are events that can occur at the same time. So if they're mutually exclusive, the probability of A or B is equal to the probability of A plus a probability of B. But what I would suggest that you remember all the time for ORs, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. That takes care of the overlap like part B. This would be the formula that I would use for the OR statements for the rest of this course. Okay, let's take a look at the next example. So suppose you roll a 10-sided die once. The numbers on the die are 1 through 10 inclusive. Determine the following probabilities. So remember the sample space I'll write. That's going to be 1 through 10. What's the probability you're going to roll a 3 or a 9? So the probability of a 3 or a 9 is the same thing as the probability of 3 plus a probability of 9. Probability of rolling a 3 is 1/10. Probability of rolling a 9 is 1/10. Add them up, that's 2/10. That simplifies down to 1/5. Okay, let's take a look at part B. You roll an even number or you roll a number higher than 7. An even number is any number that ends in a 2, a 4, a 6, an 8, or a 0. So on a 10-sided die, your even numbers are 2, 4, 6, 8, and 10. So probability of rolling an even number or a number greater than 7 is equal to the probability of an even number plus the probability of rolling greater than a 7 minus the probability of rolling an even number greater than 7. So there is going to be some overlap here. So the probability of rolling an even number, there's 5 of them, so 5 out of 10. Greater than 7, that's 8 or 9 or 10. That's 3 numbers. And in this case, how many even numbers are greater than 7? Well, that's 8 and 10. So I got to subtract out the overlap. That's 2/10. That is going to be 6/10. Divide top and bottom by 2. That simplifies to 3/5. Okay, let's take a look at part C. You roll either an even number or a prime number. So let's write it out. So again, this is the probability of rolling an even number plus the probability of rolling a prime number minus the probability of an even prime number. Okay, even we've already done, that's 5 out of 10. Now remember, a prime number is any number that has exactly 2 factors, 1 in itself. So on the side here, I'm going to do prime numbers. Well, 1 is not prime or composite, so that doesn't work. 2 does, because 2 times 1 are the only factors. So is 3, so is 5, and so is 7. So I have 7 prime numbers. So 4/10. Well, how many of those 4 are also an even number? Well, the 2 is a prime number, and it's even. So we're counting that twice. I've got to subtract out 1/10. That is 8/10. And that simplifies to 4/5. So again, I always have to write the word or out. If I see the word or, I'm going to be adding the probabilities.